Okay, students, so this is a hypothesis test for a mean when this population standard deviation sigma is unknown. Now this problem is about trout length. What I've already done is collected the important information stated in the paragraph off to the side, so I just jotted it down after reading. Now it's important to note that they don't say that the trout length, which is the variable of interest, they don't say that that comes from a normal distribution. So we do need a large sample size, which we have. We have a large sample size of 51. But we also don't know the population standard deviation sigma, so we're going to use a t-test. Now, in other courses, or it depends on really who you are, some people think that if you have a large enough sample size in greater than 30, then you can use a z-test, meaning you can use this sample standard deviation to just estimate sigma, and you can proceed with a normal distribution or a z-test. And that's acceptable. What's going to happen, what's going to result from that is you're going to get some smaller p-values. And so what we do is, because I come from a more traditional background and certainly a more conservative background, and when we don't know sigma, we go with a t-test because that's going to give us just a little bit larger p-value, and that's going to help us avoid making type 1 errors. So it's just a little bit more conservative approach. Either way is technically acceptable. But what we do in this course, in my course, is we go traditional conservative method. When you don't know sigma, you use a t-test, okay? And that helps keep things simple, especially since you're just starting out. You're just starting to learn. It's just pretty straightforward. When you know sigma, use a z. When you don't know it, use a t. And that's just another reason I go for the more traditional conservative approach to hypothesis testing with means. So I just wanted to cover that because some of you who are interested in statistics might have been asking yourself some questions like that. Okay, so let's go ahead and get into the problem. H0 is the length that they are claiming. They're claiming that the trout are a length of 19 inches. And they're wanting us to test to see if the average length is actually less than 19 inches. So this is going to be a one-tailed left test, a left-tailed test. Alpha's 0.05. Degrees of freedom are pretty large. Our sample size is 51 minus 1, so we're going to be doing 50 degrees of freedom here on our critical value method. So we'll get out our t-test. We've got a one-tail area. Alpha was 0.05, and we're going to go down to 50 degrees of freedom, which is 1.676, but it's a left-tailed, so it's a negative 1.676. Again, because we've got this left-tail test. So we're shading the left tail, negative 1.676, and we're going to label that our rejection region. Now that's the critical value. If you're doing the p-value method, you probably typed in the statistics in your calculator, and you were doing a t-test, okay? So a t-test in that testing menu, you were getting a p-value of, let me bring it up here, should have been getting a p-value of 0.134911, and then of course you compare that to your alpha of 0.05 in step 3, and then make your decision. Critical value method, you guys, without fancy technology, you've got to take your x bar, 18.5, minus the mean, which is 19, divide by s, the sample standard deviation, and divide that by the square root of n, which is 51. And then you calculate that, and you wind up getting a test statistic of negative 1.11585, roughly. And then you see where that falls in your rejection region. Does it fall in the rejection region, or does it fall outside of the rejection region? Well, negative 1.1 is closer over here, so it's not going to be in the rejection region. We're going to fail to reject in the critical value method. In the p-value method, p is definitely greater than alpha, so we would fail to reject as well. So our decision is fail to reject H naught. Or do not reject. We prefer in statistics the wording fail to reject. I'm just underlining that mindlessly. Fail to reject H naught. So our conclusion then, remember your conclusion has to talk in terms of your alternative hypothesis, whether or not this is true, and it's not true as far as we know. So we say based on the evidence the mean trout length is not significantly less than 19 inches at an alpha of 0.05. And that is our conclusion. Okay? So that was a hypothesis test when mu is unknown, or I'm sorry, when it was a hypothesis test for mu, for the population mean, when sigma, the population standard deviation, is unknown. In other words, we just did a t-test.